So, do the first one here. So here's looking good so far. Start at the slope intercept. Make sure we find the slope then. So start at B. Careful, it's negative. Right? And careful, it's up 2.5 over 1. So let's move that guy over. Right?
Oh, shit.
So what did you get for your answer?
Is 3 down 3 over 3.
All right, I had down or over 2.
Oh, no, I'm over 2.
Yeah, I'd say over
So
2.
I had to count 2.
And then I had like down 3.5, I believe.
Yeah, that's...
Or no, hold on a second. No, down 3. I agree. I just can't draw. So yeah, negative 2, 3 for that one. So graphically, it's as simple as making sure it's in slope-intercept form so you can draw it. So like that second one there, I agree.
Yes.
So don't forget your answer should be what? It's points, right? Or what are they asking you to do? Solve for x, right? Solve the system. So that means you need to probably put your answer in terms of y is equal then to what and x is equal to what. You know what I mean? Don't give it as 3 over 3 because that's not right. Didn't you say you changed that to negative 2 for your x?
Changed it on there.
The same deal. So for the second one, let's move on. So you did that in about 4 minutes, not too bad. Do it a little faster. For the second one, what are we doing when we have x plus y equals 3 and negative 2x plus y equals negative 6?
To put it into it.
Yeah, so get y by itself, right? put in that form you're familiar with, which is slope intercept form. So we get first one, and then 2x minus 6. I have to go all the way down to 6. Up to. What'd you get for that one? I don't miss there yet. Real quick, substitution method. What does that mean to you?
Like,
how do you go about it? So if I had something like x plus 2y equals 10.
So when you take the answer from the top and plug it in, or the...
Doesn't matter. Yeah, one of the two. So substitution just means you get one of them. Like I always pick the easy one, right? So I'd always say pick the easy one. And by that, all I mean is the one that's super easy to solve for. So in this case, I would subtract both x from both sides. I get y is equal to 6 minus x. Now, what do I do with this right here?
Y is equal to 6 minus x. Don't you plug that in up top for the...
Exactly. So I can't plug it into the equation I just used, right? So yeah, I plug it in there where I see y, right? So once I plug in... So plug into a different equation, because if you plugged it in and this, you'd find this out in the test, it wouldn't make any sense. As you would just get 6 minus x equals 6 minus x, and that would be correct. Like, yes, that's true. You understand what I'm saying? If you plugged it in right here,
yeah,
it wouldn't be useful at all. So yeah, once we do that, we get x plus, now instead of, and please be careful, like you are doing the parentheses thing, like we're plugging the y in. We actually are going to plug in 6 minus x equals 10. And then you just have to distribute. So now the nice thing is you get all the x's. You know, it's all one variable that you could actually find. So just make sure you follow arithmetic then or algebra stuff. So we take 2 times 6 gives me 12. 2 times a negative x gives me...
Negative 4. Oh my.
Negative 2x. Yeah, equals 10. And then what do we do now? Panic? Do you remember? I'm a little nervous to ask.
Yeah, I'm panicking now.
So what do we do? So we have a whole bunch of different terms, right?
Yeah, like terms.
Yeah, combined like terms. So, you know, I have my negative 2x and x there. So I'm going to say x minus 2x is negative x. Now, I don't want to combine the 12 and 10 yet because they're not on the same side, right? So right now I still have negative x plus 12 equals 10. So remember, you only combine like terms if they're on the same side. Do you remember that?
Yeah.
Find like terms only if on, or once on the same side.
It was like the first, because we had a half day today.
Of course you did.
We ended at like 11.
So I'm going to subtract 12 from both sides.
So I spent the first, it was first 6 periods. I was doing this testing thing when I came back. And it was more like a verbal test kind of thing.
Yeah.
This lady. And a lot of it was numbers.
Yo, is this completed? So it looks like it is, right? Because I drew the box around it.
Yes, it's not completed.
Why? What do I need to do?
You need Y, don't you? Or you already have Y.
Before I even get to Y. So yeah, you're right. I almost have X, but notice I said X, not negative X.
Oh, so then you positive 2 then?
Yeah, so you divide everything by -1, right? To get rid of that. So you're right. It's just X is a +2. So now that I have that, what do I do with this now? You tell me.
Graph it?
Nope. I only know what X is so far, right?
Oh, we haven't gotten Y yet?
Good. So what do I do?
So you have to plug that into the Y's.
Does it matter which equation I use up here?
The one that you didn't do?
At this point, it doesn't matter at all. So remember I said pick the easy one up here? Guess what I'm going to say here?
Pick the easy one?
Yeah, pick the one that looks pretty. So again, we want to work fast. So pick the easy one. So go back into one of my 2 originals. So it has to be one of your 2 originals though. So one of 2 original equations that were given to you. So I would just do that bottom one. Looks not too bad. So I'm going to go over here now. Get X plus Y equals 6. Plug in 2. And you can tell that Y is going to be equal to -2 on both sides. Y is equal to 4. And that should be my 2 answers. Now, if you get stuck tomorrow and it says elimination method or substitution method, at least to make sure you got the right answer in the end, don't forget you could do the Y equals, plug these things in. Now, here's the thing. These aren't necessarily the Y equals format. So if you have time, you can do that, but you'd have to solve for those. But you would get, let's see here, 10 divided by 2. So 0.5x, -0.5x. Let's see here, divide or +5. And then the other one would be Y equals -6. Or sorry, 6 minus x. Hit graph, and what do we get? X equals 2, Y equals 4. That's exactly what we get there, 2 and 4. So we're good. All right, so I want to see, so that's substitution method. If we did the same one, so I'm just going to use the same numbers with elimination. Move that over a smidge. There we go. Give myself some room. So with elimination method, I want to get rid of one of my variables. So it's literally, I shouldn't just call it like adding or subtracting equations is the way I look at it. So I usually put a line here and then I think to myself, what can I add or subtract? Or sometimes you need to multiply or divide things as well. So in other words, I need to get rid of either the x's or y. So if I just look at this, can I easily, if you have the same coefficients, so that's what you're looking for, like same coefficients. You know what coefficients are, right? So that's a number in front of my x or the number in front of my y. In both equations, that usually means that's the one you want to use. So for instance, I have a 2y and y. If I were to subtract this entire thing, what would happen to my x's? So if I did a little subtraction symbol here, and make sure you line up your variables as well. So make sure you have x's and y's lined up. So what's x minus x give me?
X minus x?
Yeah.
X? No, no x, just 0.
It's just 0, right? And then now here's the thing. If I minus this, and I almost I kind of want you to distribute that immediately. So this turns into a minus sign. That means you have to minus the entire equation.
You're just sitting in my pocket.
Nice. Football championship?
Yeah, Central made the Whippies.
They already played the Whippies. Wow.
I think they're playing...
Everything must be earlier this year. Usually it's, I think, Thanksgiving. Because they moved it up, huh?
No, they played the Whippies. I think they're playing, like, states.
Yeah, huh.
Because they're playing at Heinz.
That's cool. So anyway, remember the original equation was x plus y equals 6. So I changed the signs in front of everything. That's the important part. So x minus x was 0. What's 2y minus y give me?
2y minus y, 1y.
Yeah, so just y. And then what's 10 minus 6? It's going to give me 4. So I now know that y equals 4. Now, I don't know if your teacher allows you. What I would do after this, I would just plug in, again, to the easy one. So I take my new knowledge, plug it into one of my equations. So, for instance, I have the x plus y equals 6 equation. I know that y is now equal to 4. So I just get x plus 4 equals 6. So I subtract both sides by 4, right, JP? Get rid of the 4. Knock some of this rust off from your vacay. So I get x equals 2. So that would be one way to finish elimination. The other way, depending on your teacher's methods, if they expect something, would be I'd have to try to eliminate the other variable, which this is worth showing you because you should be able to do it both ways. Plus y equals 6. So in this case, I would want to get rid of the y and have x left over. You ready for this? So I need to have them have the same coefficient, right? Because otherwise you can't subtract something from something else with the same coefficient, with a different coefficient and get 0, right? In other words, we're trying to make the y's disappear. So what would this have to be to make 2y plus or minus what gives me 0?
2y minus 2.
Exactly. So you said minus 2, right? So right now the coefficient in front of this y is really a 1, right? Yeah, I'm going to do it in a different color real quick. So you said minus 2, right? How do I get this to be a minus 2? Well, I have to multiply everything by what?
2.
Minus 2.
Minus 2.
So I'm going to rewrite the top real quick. X plus 2y equals 10. And I'm just going to distribute my minus 2 to all these, right? So I have minus 2 times x gives me negative 2x minus 2y is equal to negative 12. And now this is set up where I can actually solve for this. So x minus 2 gives me
negative x, 2x.
2y minus 2y.
0.
So these terms go away. And then 10 minus 12 is negative 2, right?
Yeah.
So not quite done here yet, and you could kind of always drop the equal sign straight down, keep everything nice and neat. We just had one earlier like this. Is that solved for x quite yet?
No.
So what's that?
I can do one of the equations. Easiest. Or wait, no.
No, I just need to get x by itself, right?
Oh. Minus or positive x.
Equals what?
Positive 2.
Good. Yeah, just change the signs, right? So notice I get the same answer as I did there. So I don't know if with their elimination method they want you to do it by elimination both times or just for the first step. You'd have to find that out from your teacher. I personally think, yeah, I mean, it's good to know the way we did that there because sometimes if none of your coefficients match, like if I had to get rid of, if I had 3x and 1x and 2y and y, you'd have to figure out a way to make the coefficients match. So that's why I wanted to show you this right here because that's important to know. Oh, I want to get rid of y's. Well, how do I get this to be the opposite of that? Just multiply everything by that coefficient. Okay, so it's kind of a pain. I rewrote it just so I could have it nice and neat, but that is important because my guess is on the quiz you'll probably have one that you'd have to do that. And if you have time, you can always try via substitution and see if you get the same answer. All right? Again?
3y.
If I add them right now, it would just give me 6y. So
no,
I can't add.
Nothing cancels out.
Okay, so what can I do?
Solve it?
Mm-mm.
No.
if I had a negative 3y, things would cancel out, right?
Yes.
So how do I get that to be a negative?
Divide by negative
Nope. Oh, yeah, possibly. Keep going.
1.
Yeah, that's a fancy way of saying change the signs, right?
Mm-hmm.
You're correct. So yeah, I could change it to 8. So remember, that's everything, right?
Yeah, so it'd be negative 8
Mhm.
x plus or minus 3y
Keep going.
plus 25.
Good. Now go ahead and add them.
I just add straight down, right? Just,
Yeah, so everything's lined up for you. So your teacher is nice that they line everything up. But don't let it freak you out if it's like y plus x equals, in the one equation. You just rearrange it. So don't forget, you have to get the variable. Well, no, you're still not done yet. Remember, you have to get the variable by itself.
yeah, so minus or plus 3x, right? Or divide 3x.
There you go. Good. Now, the only thing is, you have x or negative x equals 2. Which one do you have? Good. So x is equal to negative 2. Good. So then, again, I assume you could now plug that back in. So pick both these equations. Does one look easier than the other?
Okay with this one.
Yeah, whichever one is your favorite, right? These look equally as challenging.
So
Yeah,
I
just plug it
this
back in.
for x, right?
Yeah, exactly. I mean, you want to do it for y, right?
5 times plus 3y.
No. All right, so I guess this technically should have a +1 or +2 here. So what would I shade in and y? So if I have y must be greater than 3x plus 2, think about what that means.
Which
So
line
here's-
is this one? This is
So 3x plus 2 is this line right here.
so it's a solid line and it gets shaded in on this side, right?
Where at? Here, you shade. That's 1. That's not my 3x plus 2. Remember, so it means it has to be above that line, right?
Is it, no? Just making more room.
So it's anywhere above this line, okay?
Isn't it the direction that opens? Or is it...
Right, so the alligator's going to eat this, which means y must be greater than, right?
So the shading goes on that side, right?
Yeah, on this side right here. And I stopped there for now as I wanted to look at this one. So for sure, I know this, and then we'll see what this says here. So y is less than negative 1/2 x.
So then this would get shaded up here, right? This whole.
So it literally means, okay, everything that would be. So if I shaded less than y, negative 1/2 x, it would be all of this, okay?
So then this would also be shaded in down there too.
Right, so that would just be this one. So if I actually only wanted, if both of them had to be true, it would actually just be what's left there.
Mm-hmm.
Remember that? So yeah, this is the only section right here that satisfies both those requirements. So it's above this one, and it's below that one. Now in terms of the line itself for the 1/2 x, is my line correct or no?
Yes.
Should I have a solid line?
No, the bottom one should be dotted. The
Right,
top one should
exactly.
be solid.
I thought they had a dash on here. Maybe not. There it is. So yeah, this one right here should be dash then, right? Because it doesn't have the equal to. All right. So you remember the most part, how to do the inequalities, right? So let's get a couple of those in so we get some practice. Same ideas apply in terms of solving. Just don't forget if you have, man, most of these are already in terms of y equals, huh?
Did you guys have school yesterday for Veterans Day or no?
We did, yeah.
There's a lot of schools that had school.
I think you're right. Here, try it, put in the calculator.
I gotta remember how to do this.
I know, that's what we're practicing, right?
I messed up my calculator.
Y equals up top. If you have it with you, I
I
could.
just gotta delete it, right?
Yeah, if you have it with you, I could see if I could fix it.
Nah, there's like school calculators. So,
Let's see here, minus 3.
how do I get that greater than sign?
Good question. I don't think you actually.
I forget if this is the.
So yeah, don't forget with these, I do want you to label your lines.
Is this the equation that I was on? Is this the one I've already graphed, or is I just in like?
So that's the thing. When you do these, make sure you absolutely label your lines because you'll get yourself confused. It's negative 2/5 x minus 3, right? So it's y is less than that one, and that means at least label one of the two so you know which one's what. You know what I mean? You don't necessarily have to label both. And then y is greater than this other one. So
we're done at 5:15, right?
yeah. So
where? I think my mom thinks we were done at 5.
Okay. So anyway, where is it greater than this one and less than that one? It would be all the way down here. Man, that thing went way down. Yeah, leave plenty of room whenever you do that one. So a couple things. I think you're going to be fine if you clean up that's like your 4th one in a row. How are we going to have you remember slope tomorrow? So don't forget.
Test tomorrow?
Or whenever you take it. Don't forget slope
you know about something I don't?
I know you need to make these quizzes up, so I'm just assuming they're sooner than later.
Yeah.
So don't forget, it's rise over run. And, if you have a negative 2/5, I always just say down 2 and then over 5. If you want to do the opposite, you can, but that would mean you'd have to, and I don't know, I would just keep the negative, pick one side, top or bottom, but that's what you have to do. If you want to do the opposite, you want to make 2 over negative 5, you can do that, but remember, make a decision with that negative. Don't have it hanging out in the middle, like this is bad, I hate when students do this, because then mistakes happen. Like, don't do that. Like, make a commit to numerator or denominator. As long as you have it in either thing, these two are fine. Like, because this would tell you, oh, or I could go, I don't know, up to over 5, negative 5 this way. So I'm running into my thing, but you could do it either way. Mm-hmm. Okay? But just make sure you commit with that. All right. That one is a toughie because you just have to divide by 5. But just so you don't freak out, remember you want y equals by itself. And what else did I tell you to do? Label at least one line. Because otherwise, I think you might forget which one is supposed to be greater than or less than or whatever else. So label one line. You never watch my videos, by the way, I share with you.
On YouTube?
Yeah, I could tell if you watch.
Yeah, because it has a view counter.
Mm-hmm.
The last email I got you from you was that, which is the video, isn't it?
Mm-hmm.
Yeah, I kind of forgot to watch it.
It's okay. I'm just saying, if your mom or dad say,
yeah,
is he studying? Or I'm like, I just let you know. I could say he actually never watched it once. Yeah. Not that you always have to watch, but in case you're studying, you have a question. Yeah, you might want to though.
Is there like a surplus store of just 3D printers, like what's that, the filament or whatever?